Welcome back to Next Wave News. Today we're diving into a discovery about how animals grow. And it turns out even creatures as diverse as sharks are following a surprisingly simple rule. Sharks range from tiny pygmies to massive whale sharks. Scientists wondered, how does their shape scale with growth? The answer lies in simple geometry. As a 3D object grows, its volume rises much faster than its surface area. For example, double a sphere's size, and its volume jumps 8 times, but its surface area only 4. Biologists found sharks follow this mathematical rule with striking precision. This matters because the shrinking surface-to-volume ratio changes everything from heat loss and oxygen intake to movement. It suggests physical constraints, not just environment, guide evolution. For example, animals exchange heat through their surfaces, but their mass is in their volume. If you grow bigger, you gain lots of volume, but your surface doesn't keep up. So how you lose heat, how you take in oxygen, how you feed and move all change. So the fact that sharks of different sizes align on a scaling rule implies that many of their structural and functional traits may be bound by physical and geometric laws, not just by their environment or evolution alone. The technique used was also quite advanced. Researchers built 3D models of the shark bodies using CT scans and photogrammetry. They computed surface areas and volumes digitally, much more precise than older methods like skinning animals or water displacement. They then compared how those measurements grew across species of different sizes and found the scaling held remarkably consistently. Of course, there are caveats. For one, the study focused on external surface geometry and didn't capture all internal complexities, like gill surfaces or internal organ shapes. Some experts suggest that if those internal surfaces were included, the exponent might shift slightly. Also, sharks are arguably more uniform than many other animal clades. They share a basic body plan. Whether this same scaling rule holds across mammals, birds, insects, or highly varied body shapes remains to be seen. But the key takeaway is this. Despite biological diversity, geometry and physics appear to impose constraints on life. These underlying rules shape how animals evolve, how they grow, and what forms they can take. And by better understanding them, we might gain deeper insight into biology, evolution, and even how we design biomimetic structures and robots. If this peek into nature's hidden math got you thinking, don't forget, like this video, hit that notification bell, and subscribe to Next Wave News so you never miss our next wave of science stories. Thanks for watching, and as always, stay curious.